Hello, everyone, and welcome back to Chapter 5 Rules of Differentiation. So, now we're going to enter the realm of more complex, equations where, of course, our end game is always the same. We want to compute the derivative of the function. So our next category of functions are the ones that we create by product. So if you have a function of the form u times v, so f is the product of two functions, the rule that you have to use is called the product rule. Okay, so no big games here. Okay, so if you see a product, you do the product rule. So the only thing you have to be very careful is that when you see a product, and if you're asked to compute the derivative, if you compute u prime and v prime, and you just take the product of those two, you will get zero. Okay, so the goal of a question about rules of differentiation, and your question starts as a product of two functions, you have to show me that you're using the product rule. So the rule is the following. So if f is u times v, then f prime is u prime times v plus u times v prime. So even if you start with only one term, which is a product of u and v, you get two terms for your product. And the way I remember the formula is that it's as if, like, when you look at these two terms, you're only differentiating one term at the time. So you start with uv, but you only differentiate u first, and then you multiply by v. And then the second term is you leave u alone and you differentiate v only. Okay, so u prime v plus u v prime. So one way to do a product rule correctly, especially when you're learning it, is to first label the two functions that are a product here, and then compute separately what u prime and v prime are, and then combine these four functions in the product rule. So anyways, the best way to assimilate this function is by doing examples. So first function, suppose f of x is x squared times sine of x. So I have x squared times sine of x. So it's the product of two things. So I'm going to call the first function u. So u will be x squared, and v is going to be sine of x. So you just label your function carefully, and then you compute their derivatives. So here u prime is just going to be 2x, and then v prime, the derivative of sine, is cosine. And once you have these four functions, you combine them. So it's u prime first, so 2x times v, which is sine of x, plus u, which is x squared, times v prime, cos of x. And that's all. Okay, as long as you combine things properly. If you remove brackets here, you can simplify a bit. I don't really care if you do that or not. Okay, so, but if you want to have like a bracket-free answer, here you go, 2x times sine of x plus x squared times cosine. All right, let's do more examples. So next function, the root of x times ln of x. So u will be root of x, and ln is going to be ln of x. So here, root of x for u, ln of x for v. When you differentiate root of x, remember, root of x is x to the power 1/2. If you use the power formula, you get 1/2 x to the power minus 1/2, which simplifies to, you don't have to use a simplified format, but root of x is one of those functions that you differentiate so many times in calculus that you might as well remember it as one of those basic formula. So the derivative of root of x is 1/2 root of x. And for v prime, if you have ln of x, then you're just going to get 1/x. So now I have my four functions, and then I just combine them. So it's u prime 1/2 root of x times v, ln of x, plus u, which is root of x, times v prime 1/x. If you're really in the mood to simplify this would be fine on a test though, or in web work. So you get ln of x over 2 root of x. You write this as one fraction, plus root of x over x actually simplifies to 1/root of x. It does not really matter. Okay, so again here, what's really important for those two examples, so you see it's a product, you label u, you label v, you compute u prime and v prime, and you combine these four functions with the product rule. Okay, u prime v plus u v prime. And you don't really need to simplify. Okay, so and if you can do it without labeling U and V, so if you can find the derivative if you can find the derivative of using the product rule without going through the labeling process, and you will see with some of my examples that we'll do that eventually, especially when we're combining more than one rule, it's fine too. Okay, so when you're learning it, it's good to label U, V, and etc., compute U prime and V prime, and then combine everything. All right, let's do another example where we have the product of three things. Oh no! Okay, so here we have x4 times ex times cos of x. So, oh no, the product of three things. He did not tell us how to do the product rule of three things. He's a bad teacher. I know I'm a bad teacher, but the product rule can be done. Okay, there's a fork that moved in my sink. That's a bit scary. I'm alone. My dog is not there. Anyways, I'm a brave man. I'm a brave man. That's what my therapist says. Anyways, so x4 times ex times cos of x. I'll just regroup these two as a product of two terms. The first one is going to be x4. It does not really matter how you group them. You will end at the same place, but I decided to group x4 ex as one term. So I'm going to call this first chunk u, and the second chunk is going to be cos of x. So now what's going to happen when you compute u prime? Well, u prime, because u is the product of x4 times ex, because it's the product, what rule do we use? Well, hello, the product rule. So here you have to use a product rule. So, and now we're getting comfortable with this idea. So the derivative of x4 is 4x cubed. So it's my u prime. So the derivative of the first one times the second one plus the first one times the derivative of the second one. So, of course, when you're comfortable with the rule, you can just write it down, no problem. And then for v prime, derivative of cos, that's just a basic term, you get minus sine of x. And now I combine everything for f prime. So f prime is u prime first. I'm going to open a big bracket here. So 4x cubed times ex plus x4 times ex. That's my u prime times v, which is cos of x, plus u, which is x4 ex, times v prime, which is minus sine of x. On a test, that's enough. Okay, you don't have to go further than this. But as a remark here, I just want to show you what happens if you distribute your terms. So I'm just going to distribute the cos of x, okay, the v inside u prime, just to show you the following thing. So if I enter cos of x inside, okay, so it's just a remark. This is fine enough on a test. Okay, so you're going to get 4. So you're going to get 4x cubed times ex times cos plus x4 ex cos of x plus x4 ex minus sine of x. And what's interesting here is that when you distribute that cos and you rearrange it like this, you can, when you compare your function with your f prime with your original function f, we had 3 terms multiplied: x4, ex, and cos of x. And now how many terms do we have in f prime? We have 3 terms, where the first term is 4x cubed ex cos of x. So when I compare it with f, the only term that changed is the 4x cubed, which is the derivative of x4. When I look at the second term, I have x4 ex cos of x, which looks like the exact same thing as the original term, but really I took the time to keep my derivatives in brackets here. So the only thing that changed but did not change is that the ex became ex because it is its derivative, and the last term is x4 ex times minus sine of x. And when you compare with f, it's the exact same thing, except the cosine became minus sine of x. So one way to differentiate quickly, and I'll just write this as a remark here, and you can do this. If you have the product of 3 terms, you can get the derivative of the product of 3 terms using the following. Boom. Okay, so if f of x is, let's say, u times v times w, then f prime is U prime VW plus UV prime W plus UVW prime. So there's careful in your notes here. Might have written a plus instead of a product. And actually, this idea works for 4 or 5. If you had like the product of 4 terms, let's say A, B, C, D, it would be A prime B, C, D plus A, B prime, C, D plus A, B, C prime, D plus A, B, C, D prime. So you can really get the derivative of a large product very efficiently that way. But anyways, typically in this class, the product rule will be, of 2 terms will be what we need, like in general. So you don't have to worry too much. All right, that's it for that example. Let's move on to the next rule, the quotient rule.